The C programming language consists mostly of expressions and statements. In fact, many statements are also expressions and vice versa. Let's make a working copy of working.c from the Chapter 3 folder in the exercise files, paste it into the working project, and double-click to open it. And this is our simple Hello World program, so if I press the green run, it'll compile it and run it, and it displays the constant string Hello World. But what you may not realize is that printf is also an expression. It is a function that returns a value, and that value can be assigned, it can be calculated with, you can do all kinds of things with it. So let's assign it to a simple integer variable here, x equals, printf returns an integer value, so I can print that with another printf statement. So that's printf, and the constant string printf returned %d, and a backslash and an n, which represents a new line, and then comma, and the x variable. So that x variable will be used for the value of this %d. So it'll say printf returned and a number, and that number will be the number returned by printf. The value that printf returns is the number of characters that it printed. So in this case, there's 5 characters in hello, there's 5 characters in world, you have a comma, a space, and a new line, and an exclamation point. So that comes out to 14 characters. So when I run this, compile and run, see it says printf returned 14 because it printed 14 characters. Now, in fact, because printf returns a value, that value can be used on the right side of an expression, as it is here in assigning it to x. It can also be used on the left side of an expression. So I can say printf times 5. So it'll take that value 14 and it'll multiply it by 5 and display that. So I'm going to save and compile and run. You see returned 70. Well, printf actually returned 14 and then it got multiplied by 5. But x here is now the value 70 because we multiplied it by 5. So in fact, the printf statement is also an expression. It calls a function and that function returns a value, and that value can be used in calculations. It can be used on the right or on the left side of an expression. So really most statements are expressions. What makes an expression a statement is the fact that it's terminated by a semicolon. So this entire statement here is a statement because it's terminated by a semicolon, but it also includes a few expressions. And this expression here, even though we're not using the value of it, is still an expression. It's also a statement because it's terminated by a semicolon. So very specifically, an expression is a unit of computation. An expression has a value. That value can be void in some cases, which means it can't be used, but it's still a value. A statement, on the other hand, is a unit of execution, and a statement is terminated by a semicolon. Multiple statements can be grouped together with curly braces. These are called compound statements. They're also sometimes called blocks. Unfortunately, the term block also has other meanings, so you'll need to be careful of its context, where you see it and where you use it. You can use a compound statement anywhere where a statement is allowed, but they're commonly used with control statements. For example, I can put all of this inside of a loop. I can say for int I equals 1, I is less than or equal to 5, and increment I. All of that inside of this block, and I'll go ahead and indent those so that we can see that they're inside the block, but really it's the curly braces that make that a block. Now, both of these statements will be executed each time we iterate this loop. So I'll save this and we'll run it. And we see now this is getting run 5 times. Hello world, printf return 70, hello world, 5 times. And that's because all of that is inside of that block with the curly braces. Keep in mind that the compound statement here is really a convenience. It allows you to have several statements in place where normally you would have just one. If I were to delete all of this and just put one statement here, terminate that with a semicolon, now we have this control structure, this for loop, and it has just one statement. So that one statement will get run 5 times. So I'm going to save that and run it. And we see I is 1, I is 2, I is 3, I is 4, and I is 5. So that loop got run 5 times, but it only has the one statement. When there's just the one statement, it's a single statement. So you don't need the curly braces because it doesn't have to be compound. Although it is common practice, and it's actually good practice, when you have a control structure to go ahead and use a compound block anyway, even when there's just one statement. You notice that Eclipse put in both of the brackets there for me and indented and everything The reason you want to use the braces in the compound structure, even when there's only one statement, is if later on you decide to add another statement, you already have the braces and you already have the block. Otherwise, it's possible to forget that, and even though you indent it, not having the braces, it won't be part of that block. So it just prevents errors. I'll go ahead and save this and run it, and you see that those all get run together each time through the loop. Statements and expressions are the building blocks of the C language. While statements are often also expressions, understanding the distinction is important to becoming a proficient C programmer. Now let's delete the working file and run clean to get set up for the next lesson.